Now, what is resultant force? Resultant force is a single force that represents the vector sum of two or more forces acting on an object. Next, we will discuss resultant force in three situations. Situation 1, force acting in the same direction. So look at the diagram. I am sure that the students can come up with the correct answer. Yes, the answer is 8 Newton to the right. Remember that for vector, you must include magnitude and direction of the force. Next, situation 2, force acting in an opposite direction. The resultant force in this situation is 8 Newton minus 3 Newton. The negative sign in 3 Newton is to show the direction of the force. The resultant force is, yes, 5 Newton to the right. Situation 3, forces acting in perpendicular to each other. In this question, a force of 4 Newton and 3 Newton is perpendicular to each other. When two force vectors are perpendicular to each other, their resultant force is drawn so as to make a right-angled triangle. In the other words, the resultant force vector is hypotenuse of their triangle. So we need to apply theorem of Pythagoras. Now, the resultant force Fr equal to the root of 3 square plus 4 square, and the answer will be 5 Newton. So what is the angle of the force? So the angle of the force is arctangent 3 over 4, which is 36.9 degree. Situation 4, forces which are not perpendicular to each other. There are two ways to determine the resultant force for forces which are not perpendicular to each other. The first one is through triangle method. For example, look at the diagram here. There are two forces, F1 and F2, which are at an angle of 50 degree to each other. F1 and F2 is 30 Newton and 40 Newton respectively. Determine the resultant force. The first step is scale. Choose a suitable scale to draw lines that represent the magnitude of the forces. For example, 1 centimeter equal to 10 Newton. Number 2, ruler and protractor. By using a ruler and a protractor, draw the force F1 followed by F2 to form two sides of triangle. By using a ruler and a protractor, measure the resultant force vector. In this question, the reading of the ruler is 6.3 cm, thus it needs to be changed to the scale 1 cm equal to 10 Newton. So, the answer will be 63 Newton and the angle is 28 degree from F1. Again, situation 4, forces which are not perpendicular to each other. For example, look at the diagram here. Two forces F1 and F2 are at an angle of 50 degree to each other. F1 and F2 is 500 Newton and 400 Newton respectively. Determine the resultant force. In this question, we use scale 1 cm equal to 100 Newton. By using a ruler and protractor, draw a parallel lines to F1 and F2 to form a parallelogram. And lastly, measure the magnitude using ruler and the angle using protractor to measure the resultant force vector. In this question, the reading of the ruler is 8 centimeter, thus it needs to be changed to the scale 1 centimeter equal to 100 Newton. So the answer will be 800 Newton and 22 degree from F1. Newton's second law of motion states that F equal to ma. So when we substitute a, acceleration, to 0, when the object is at rest, or when the object is moving in a constant velocity, thus the resultant force will be 0. Aisha will help to explain more about Newton's second law in equilibrium of forces. From equation F equal to ma also, if we substitute acceleration to certain magnitude, thus, when acceleration is not equal to 0, the resultant force also will not be 0. So there is force acting on the object. To find the resultant force, F equal to ma. We will learn the resultant force further in Tarik Upir game.